Hello everyone. So in this video we will discuss chapter number 4 part 2. If you remember, in the part 1 we discussed the definition of authentication. We discussed what is basically authentication, and we also discuss factors of authentication, like the application layer authentication, factors of authentication. And if you remember, we discussed 5 factors of authentication through which we can perform authentication. The third, we discuss some schemes of authentication at transport layer. If you remember, we discussed cipher text-based authentication, MAC-based authentication, and hash-based authentication. If you remember, we discussed all these with different scenarios, with different concept, in fact. So in this video, we are going to discuss some formal authentication models. We will discuss formal authentication models, and specifically we are going to talk about 3 main models. First is the HMAC, second is Kerberos, and the third one is OAuth 2.0. So HMAC, it stands for hash based message authentication code, MAC. Kerberos is basically a protocol that typically we use if we have a multi-vendor environment. If you have a multi-vendors products in your organization, to manage those resources, we use Kerberos typically to manage the access of those resources. OAuth is basically a cloud-based access control system. We will discuss that in detail as well. So in an organization, typically for transport layer based authentication, they use HMAC, and definitely they also use Kerberos. A counterpart is SAAML, security assertion markup language, and OAuth as well. So typically organization, they use all these 3 schemes, in fact. So let's see what is basically HMAC, what is Kerberos, where exactly we use Kerberos, and OAuth. Let's start with that. So starting with the HMAC. So HMAC, if you guys remember, first of all, let me just tell you, HMAC is basically advanced form of MAC, or you can say it's a hybrid scheme of MAC plus hash. We will discuss that. So just to recall you guys, if you remember MAC, message authentication code. So in message authentication code, it is just like your just like the hash function, but it requires a key. So for example, just to give you idea, let's say if you want to calculate a MAC of the message to perform authentication of user, like sender or receiver, and protect the integrity. So typically what we use, let's say this is your message or a plain text. So what we will do is, and if we use authentication function, so use authentication function, and it requires a key. So a pre-shared key, both sender and receiver, they should have this key to generate the message authentication code. So this message authentication code is, first of all, irreversible. Irreversible, it means if anybody has your MAC, they cannot extract the message. Only thing that what we can do with the MAC is we can perform authentication of the sender, or the receiver can also be authenticated. So we can perform authentication, and we can also protect the integrity of the message, like message has not been altered during communication. Same thing like in the case of hash. Hash is basically keyless. So it's not required that both sender and receiver, they should have the same key, but they should have the same algorithm. So let's say this is the message, and if you calculate a hash value, pass it through a hash algorithm like SHA1, MD5. So this is your hash value. So we typically use this hash value to perform authentication. So if you see here, there is no key required. So hash is basically a keyless, and this hash value is used as authenticator. Again, it is irreversible. If anybody knows the hash, they cannot extract the message. So what is the difference between MAC and hash? The main difference is MAC involves a key, a pre-shared key, and then it will let you calculate a message authentication code through which one can authenticate the sender and also protect the integrity. In HMAC, if you combine both of these, so in HMAC is equal to, it involves a hash algorithm plus a key. So again, we don't actually use a key direct to hash algorithm. It's basically a scheme where we also use a pre-shared key, but we also involve the hash algorithm. So this is basically what the HMAC is. HMAC involve hash algorithm plus a key. So please remember that it's important from quiz point of view as well. So let me just enlist the steps, because there are 8 steps involved to calculate the HMAC. Okay, and there are a few requirements that you need to know. So let's see what are the requirements, what are the different steps. I will enlist all those steps at the end as well, but let me just give you a simple example of the pre-reg. So the steps involved in calculating or computing HMAC. So it mainly involved 8 steps. So let's see what are those 8 steps and how we can calculate the HMAC. First thing that you need to know is the most important things to remember. These are some things to remember, not the steps. Things to remember before we start constructing a HMAC. The first step is pre-shared key. So this is the key, K is a key, and both sender and receiver pre-share this key. So both sender and receiver, they pre-share this key, number one. Number two, let's say your message, M is the message. M is the message, or you can call it as the plain text, whatever you want to name it. So M could be something like that, and the M is broken, or you can say divided into blocks, same size blocks. And the block size is B bits. Just for the understanding. And let's say this is basically how the message look like. So this is your whole plain text message, which is divided into number of blocks. Let's say L number of blocks. So let's start with M1, M2, M3, M4, and all the way ML. And the size of each block is B bits. I mean, B bit could be 8 bit, 10 bit, 20 bit, or whatever you define. Okay, depending upon your algorithms and your hardware, in fact. So let me repeat. There would be a key. Both sender and receiver, they should have the key. Second, the message should be divided into blocks of equal number of chunks. Like they should have the equal, having the same size of the chunks, and the chunk size is B bits. Number 3 requirement is, beside the key, they also pre-share some other paddings. And one padding, there are 2 paddings that they actually share, like both sender and receiver. They pre-share, both sender and receiver pre-share paddings. So which padding? iPad is equal to something like any number. It could be something like 0, 1, 0, 1, 1, 1, 0, something like that. But the size of iPad is B bits, the size of the block. It's exactly the same. There is another thing which is called OPAD, and the size, it could be something different, 1, 1, 0, 1, 1, something like that. But it should be equal to B bits, the same size of the block. So please remember that these are the 3 very important things that you need to know. The first thing is to construct or to compute a HMAC. The first thing is key. Both sender and receiver, they pre-share this secret key. Number 2, message is basically divided into blocks, and the size of block is B bits. Let's say M1 is basically the block of message, and the size is B bit, because it's typically we use a block cipher with HMAC, so that's why we make it compatible. Padding, both sender and receiver, they also, beside the key, they also share this iPad and these 2 padding, iPad and OPAD. Okay, they also know this iPad, OPAD, and key is as well. So let's start the steps involved in constructing. Let me just draw a diagram. I guess that would be much convenient. So steps. So now let's see how we can calculate the HMAC. What are the different steps involved in calculating the HMAC? So the first step is that we need to know, as everybody knows, that K, which is pre-shared, K, which is key, it's basically a key which is pre-shared between sender, and receiver. Now the first check is if k is smaller than b bits. If you remember, b bits is basically the size of the message block. If the length of k is smaller than b bits, then what we are going to do is we will calculate k plus. And what is k plus? K plus is basically where we will append, or you can say add zeros on the left side of k to make it equal to b bits, the length of b bits. What exactly it is? So for example, let me explain you. For example, if the b bits are, let's say 8 bits, 0 1 0 1 1, so 1 0 0, for example 8 bits, and let's say key is, let's say 1 0 0 1, for example, that's the key. So keys are 4 bits. So what we are going to do is, in order to make it k plus, we will actually append 4 zeros on the left side, 4 zeros, and then 1 0 0 1. So 1 0 0 1 will be here, and these 4 zeros are added, so it should be equal to b bits. Okay, so why we actually append on the left side? Why? The reason is that so the number will not change. Let me give you the idea. For example, let's say if the value is, let's say 0 0 0 1 0, for example, this is something. If you calculate the decimal value for this binary, it's going to be 1 2 4 8. Decimal value is going to be 2. If you append the number on the left side, like on this side, let's say if I append a 0 here, 0 0 0 1 0, I just appended this 0 on the left side. So if you calculate the decimal value, you can see the decimal value is again going to be 2. But if you append the number on the right side, what will happen if you append the number on the right side? 0 0 1 0. If you append this number on the right side here, then if you calculate it, it will be 1 2 4 8 16. It's going to be 4. So you can see here the number got changed, and we don't want to change the key value. That is why we actually append on the left side. Okay, so the first step, let me repeat, k, which is pre-shared. If k is smaller than b bits, the message block size, if it is smaller than that, then what we're going to do is we will append 0 on the left side. We will pad 0 on the left side of the k unless it will equal to b bits. Okay, that's the first step. Second step is, now we got this k plus. Now let's say we have this k plus here. So the second step is going to be, we will XOR k plus with iPad. So iPad is, if you see down here, this is the iPad, which is pre-shared between sender and receiver, having the b bits. OPAD is another padding value, which is b bit, already shared with the receiver. So we will, whatever the k is, we will take a XOR with the k plus and now of iPad, and let's say the value is S1. So the k plus, definitely it will be of b bits. If you see in the previous step, we made it of the b bits. iPad is already of b bits. S1 will definitely return into b bits. Okay, now what we will do is, this is the first step. After calculating the S1, what we will do is we will actually append S1 with the original message string. So S1 will be appended on the left side. It's going to be M0, or let's say M1, M2, and all the way to ML. So this is the plain text. If you see, that's the plain text. We append the result on the left side, S1. Okay. Now next step is we will calculate the hash value of whatever we got here. And hash value will return you answer in, let's say, something like in n bits, depending upon which algorithm you have used. Now again, if n is smaller than b, then again we will pad zeros on left side of this n to make it b. Okay, we will again pad the zeros here. Now let's say we made it b bit here, or it is already equal to b bits. That doesn't make any, let's say it became the b bit result here. Then what we will do is, then we will again calculate k plus XOR with OPAD, and the result is going to be S2. Now what we will do is we will pad this or append this S2 with this b bits, and then calculate the hash again. So HMAC involve mainly two hash operators. Hash, and then the result is going to be n bits again, just like if you see, if you calculate the hash n bits, and this n bit is basically your HMAC hash code, or you can say HMAC hash code. So this is basically what the HMAC is, and that's the process of calculation or calculating the HMAC. Okay. So let me just quickly give you idea what we did. The first step is, this is the first step. In the first step, we just calculated, we just actually made the k equal to b. If it is not equal to b, how we actually append the zeros on the left side. Then after your k plus equal to b bit, we calculate the XOR with iPad, and S1 we append on the left side, calculate the hash. Whatever the answer came, again, if it is not equal to b, we append the zeros on the left side, made it equal to b bits. Then calculate the XOR of k plus with OPAD, got S2, append with this result, calculate the hash, and finally whatever we got here, this is called over HMAC, and this will provide you authentication of both the sender and receiver and protect the message integrity. Okay, the second formal authentication model is Kerberos. Typically, we use Kerberos in multi-vendor environment. If organization has multiple vendors product under one roof, they typically use Kerberos because it is fully encrypted, very secure. So what exactly happens in Kerberos, and where exactly we use Kerberos? So like a single sign-on thing. So for example, let's say this is our GGC and we have multiple vendors product under GGC. We have, for example, D2L, we have Clawmail, we have some other products as well. Let me just take example of D2L and Clawmail. So D2L is owned by this company called D2L. This is an education company. And let's say we have Clawmail is a product of Microsoft. So the thing is, we don't have their D2L and Clawmail server on our campus. All we have is, we have a server here, authentication server, AS here. And that authentication server has issued all the clients, all the students, all the faculty members one username and password. Like the thing is something like alice@ggc.edu. And you can use the same email address, same set of username and the password to access D2L and Clawmail. You don't have to have different account for D2L and different account for Clawmail. So let's understand it. So this is your authentication server who has all the username and all the passwords. So for example, you want to access D2L. So what we will do is, you will be presented a form where you need to put your username and the password. Once you put your username and password, when it will go to authentication server, after basic authentication, they will issue you a ticket, or you can say a token. And they will also forward that ticket to D2L and Microsoft as well, like, hey, this is our user and we have issued this particular ticket to this user. So they already know your ticket. So after getting the ticket, if you want to access D2L, you will present the ticket to D2L and say, hey, this is my ticket. Can I access you? So if the ticket is valid, they will allow you. Same thing, if you want to open your Clawmail, you will go to Microsoft server and you will present the ticket. So that's the way how Kerberos actually work. So users cannot access organizational resources directly, but it involves a trusted third-party authentication server, which might be hosted on your campus, or you can say on the company side. So what is Kerberos? In fact, Kerberos is basically a client server-based authentication, protocol that provides security plus authentication. It provides security plus authentication to both users and the servers. Next, user cannot direct access the resources. It involves a trusted third party. Here are a few terminologies that we are going to use. Client is basically the user who wants to access the resources. Second is the trusted third party. It is called KDC, Key Distribution Center, who knows the passwords and usernames of all legit clients. So all password, the username is known to trusted third party. And then we have the last thing is going to be organizational resource. An organization resource could be like application server, or it could be, for example, file server, etc., etc., which they want to actually protect. So let's understand how exactly Kerberos works, in fact. So let's say this is your key distribution center, which is placed or which is located on campus, and that's a file server, a remote file server, for example. Okay. So user wants to access, for example, this file server. User want to access this file server. So what will be the process? How many steps are involved and how it looks like? So let's understand it. So first thing is user will actually make a request to key distribution center. User cannot directly send request to server like Hotmail. User will reach out to key distribution center. User will send a request, and request will be encrypted with the password, user's password, which only user or client knows, or which only KDC knows. Authentication server knows all the password of all the clients. Like if you see authentication server who knows the password of all the clients. So what user will do, user will request is, hey, can I access this file server? This request is encrypted with the password. When this request will reach out to KDC, KDC will use authentication server, find your password, and then see your request and see whether you can access that or not. So after unveiling your request, what authentication server will do? Authentication server will create a TGT, ticket granting ticket, and encrypt with a secret key which is unknown to you, which is only known to KDC. So what KDC did? KDC has created a TGT, ticket granting ticket, encrypted. Let me write it down. Ticket granting ticket, which is encrypted with a secret key K, which is only known to authentication server, and authentication server will forward this K to the ticket granting center. And send this particular key to ticket granting center. Now, after doing that, a KDC will forward that ticket granting ticket, which is encrypted with a key, with a secret key, in fact, which is only known to KDC, to forward to client. Again, this is also encrypted with the password of client, which is only known to client. But I'm just making it simple to understand for you guys. Otherwise, it will involve a password encrypted and all that stuff. But let's assume that they will create a ticket granting ticket encrypted with a secret key only known to KDC and forward this to you and forward this key to ticket granting center. Now, what client will do after receiving that? Client will again reach out to KDC and this time to ticket granting center, forward this ticket granting ticket, which is encrypted. Client doesn't know that. What is that ticket? Plus the request with the password. Request, again, as you know, request is password just for authentication of the user. When ticket granting center, or you can say KDC, will receive that, they already know, they will verify the ticket because it is encrypted with K, but only known to the ticket granting center. So they will unveil the ticket granting ticket, like authorization. And after it's the same ticket granting ticket, they will issue the client a token which is encrypted with another key called K2. And then they also forward this K2 to file server. Like whenever sender will send you a token, so please use this particular key to unveil it. After you receive this token, client will now reach out to file server again, send this encrypted token. So client doesn't know what is token, what is inside the token. Client doesn't know the TGT as well because these are encrypted and these are encrypted with keys unknown to client. Client will forward this token, okay, and just try to access that. File server already got this K2. File server will unveil the token and authenticate the user. And of course, after that, if the if the file server can successfully retrieve the token, they will allow the user to access the file server. So this is basically called a Kerberos protocol. Let me quickly write down few steps so you can actually remember the things to remember. The first step, as you know, the client will forward the request to KDC. Client forwards request, which is encrypted with the password, to KDC. Like I want to access, for example, this particular thing. Okay. And this request has client ID and plus the info of the requested thing. Like what is the client request will have client, my name is this, and I want to access that. And it is fully encrypted with the password. Okay. Second thing, upon receiving request which is encrypted with a password from client, the authentication server. AS is authentication server. This is the authentication server inside the KDC retrieves the password of user of the client, password of client from the database, and decrypts the request to see the user ID plus the request and see whether user can access that or not. Okay, this is the request when it will decrypt the request. Third step is then after successful authentication server will create and sends TGT, which is fully encrypted with the key, okay, to client, and also forward key to TGC, ticket granting center. If you see, after retrieving this, verify the user ID and all that, create this TGT, ticket granting ticket, fully encrypted, send it to client, and also send this key to TGC. Okay. The fourth step is receiver will forward encrypted TGT plus the request to, again, ticket granting center. You can say ticket granting center, in fact KDC. Okay, like receive client will actually forward TGT plus the required to ticket granting center. The fifth step is the ticket granting center will retrieve the TGT, because they already know the key, and then create token which is encrypted with the key K2, secret key unknown to client, okay, and sends to client, and also sends K2 to the concerned resource, for example file server in our case. Okay, if you see TGT, they will retrieve TGT, okay, because they already got the key. If it got verified, then they will send the token encrypted to the client, and client will forward this token to file server, and also they will forward this K2 to the file server. 6, client will send this token which is fully encrypted K2 to the file server, and then file server will authenticate the user and let it use all this. So these are basically the steps that we have discussed here in the in the Kerberos, in fact. Okay, next is the OAuth. OAuth is basically you might have used if you have a Facebook account, so, and if you would like to create Instagram account, or for example LinkedIn account, so you might have seen a button which says create account with Facebook credentials or Facebook. So do you really share your username and password, the Facebook username and password with LinkedIn? No, we actually use a protocol called OAuth, which allows the user to grant access of his Facebook account to Instagram or third party without sharing credentials. So OAuth is an open source standard protocol that allows a user to grant access of his resources to a third party without sharing the credentials. Without sharing credentials. That's the definition of OAuth. Okay. Again, in our class, I'll show you guys, I'll practically demonstrate you guys. You can put OAuth in your personal website as well to collect the data from Facebook or, for example, LinkedIn even. Okay. There are two main tokens that are very important. One is called request token. Very important. We will understand that. Second is called access token. So if anybody gets your access token, they can access your account without knowing your username and password. Please remember, if anybody gets your access token, they can log in as you on Facebook. For example, if they get the access token of Facebook, they can log in as you without knowing your credentials. Okay. So access token is very important. Okay. If anybody steals your access token, they are in. To understand OAuth, let me just give you an idea. Let's say, for example, this is you, and let's say you wanna actually enroll for Cobra Kai, the karate. Okay, and you are, for example, 15 years old. You just reach out to Cobra Kai and ask them, hey, can I learn karate? So the thing is, according to the rule, you are under 18. So what they will do is they will provide you a form and ask you, get it signed from your parents or guardian. What you will do is you will go to your guardian or your parents and ask them, hey, I just want to learn this karate and please sign this form. So your parents will sign this form. Then you will go back and present that signed form to your to your instructor, the Cobra Kai instructor, and they will actually allow you or not. I mean, that's the process. This is basically what the actual OAuth is. How it exactly looks like. Let me explain you guys. So please remember this request token and access token. Very important, access token. So let's say this is you. This is, for example, Alice. And Alice, she want to create an Instagram account with the Facebook information. She don't want to put some more information over and over. So what she did is she has clicked the button which says create account with Facebook. So what basically she did? So she actually sent a message. The first request, the first step is user or Alice requests to create account with Facebook. Okay, what will happen? Instagram, they will reach out to Alice, like they will basically redirect you to facebook.com. So they will ask you request to Facebook, request to access Facebook account, request to access. Can we access Facebook or can we redirect you to Facebook? You will say, okay, no problem. I'm good with that. Okay. You'll say, okay, no problem. Let's go to Facebook. Then what will happen? Instagram will reach out to facebook.com and they will ask for a request token, like an empty token. They will ask for a request token. Like you will go to Cobra Kai. They don't have the form. They will reach out to printer and take a printout of the form. So Instagram will reach out to Facebook and ask for a request token. Now Facebook will send them request token. Facebook issues request token, R token. I'm just naming it R token, request token. Now what will happen after Instagram will get that request token? Instagram, now this is the fifth step. Instagram number 6. Instagram number 6 step, Instagram will send you the request token, R token, to get it authorized. They ask you guys to please sign it, authorize it. So what you will do is you will actually go to facebook.com because you will need to put your username, password kind of thing, and present the R token to authorize. They will ask your username and password. After you put username and password, the 8th step is they will authorize R token. Now R token, the request token got fully authorized. Now what will happen? The 9th step is you will actually forward, Alice will forward the authorized token. This is the authorized R token to Instagram. Now Instagram will forward this authorized token. This is step number 10. Authorized token to Facebook, like which is fully signed by you, authorized token. Now after getting this authorized token, Facebook will issue the Instagram, 11th step, they will issue the access token. So basically now they can actually post on your behalf. They can download, you can say they can actually pull the data and stuff like that. So authorized token and request for access token. Okay, access token. So as I mentioned earlier, if anybody gets your access token, they can actually post on your behalf. They can access whatever you're supposed to access. So this protocol is called OAuth. Okay, we will discuss that in our class. If anybody will have any questions, please do let me know. Thank you.